Okay, in this video I'm going to introduce you to definite integrals as opposed to the indefinite integrals that we saw in the previous lesson. So the way you work them out, it starts out using the exact same process that's for an indefinite integral, but now we have these numbers here at the bottom and top of the integral sign. These are called the limits of integration. This is the lower limit and this is the upper limit. And what happens is after we evaluate the indefinite integral using the same integration rules that we have been using, then we need to substitute these limits into the result. And unlike an indefinite integral, for a definite integral, we don't have a plus c to deal with because we have these limits instead. So you'll see what I mean as I work these out. So the definite integral of minus x squared, we use a power rule. We've seen that the integral of x squared is x cubed over 3. So what we get is minus x cubed over 3 because of the minus here. And then here's a new notation. The vertical bar with the limits at the bottom and the top indicate that these values are to be substituted into the expression to the left of the bar, minus x cubed over 3. So when I do that, well, the idea is you substitute in each of the limits and you subtract the results. So I have minus 5 cubed over 3 minus, and then minus 4 cubed over 3. So you substitute both limits into the function that you get after using integration rules, and then subtract them. So it's always the value at the upper limit minus the value at the lower limit, like we have here. So what we get is 5 cubed is 125, so minus 125 over 3, minus, and 4 cubed is 64, so 64 over 3. So we have minus 125 over 3 plus 64 over 3. They have a common denominator already, so we can just add the numerators. Minus 125 plus 64 over 3 is minus 61 over 3. So whereas the result of an indefinite integral is a function with a plus c included, the result of a definite integral is always a number, like this minus 61 over 3. Okay, so now doing the other ones, we have the definite integral of 5 over x with limits 3 and 4. So the integral of 1 over x is natural log of the absolute value of x. So when we apply the integration rules here, we're going to get 5 times the natural log of the absolute value of x with the limits 3 and 4. 3 is the lower limit, 4 is the upper limit. So now what I will do is substitute these limits into this function and then subtract the results. So I have 5 natural log of 4. There's no need for the absolute value, this 4 is positive. Minus 5 times the natural log of 3. Now, if I were to factor out a 5, I'd have 5 times quantity natural log of 4 minus natural log of 3. Here we can use the properties of natural logarithms from a previous chapter. A difference of logs is a log of the quotients. This is the same as 5 times the natural log of 4/3. And if you were to evaluate that in your calculator, then the 2 decimal places you get 1.44. So that's the final answer for that one. All right, and now for the last one, we have 8 plus 4 e to the x with limits 4 and 5. So using our integration rules, the integral of a constant is that same constant times x. So I have 8x. I use parentheses here. I mean, the integral of e to the x is e to the x, so I'm going to have plus 4 e to the x. So that is my antiderivative. So that would be the indefinite integral, except that for indefinite integral, I would include a plus c. But this is a definite integral, so instead I have my vertical bar with my limits. So notice, once you go from this stage to this, the integral sign goes away. The limits stick around because you need to substitute those in. So now I substitute in x equals 5, then x equals 4, and subtract. So I have, and it's a good idea to use parentheses for more complicated expressions that have more than one term. 8 times 5 plus 4e to the 5 minus 8 times 4 plus 4e to the 4. This is why it's a good idea to use parentheses, because you always have some minus that you're going to be distributing through a larger expression. So now when I simplify this, I have, 40 plus 4e to the 5 minus 32 minus 4e to the 4, and I can condense this a little bit. So that would be 40 minus 32 is 8 plus 4e to the 5 minus 4e to the 4. And if I were to evaluate this expression using a calculator, I'll go ahead and do that real quick. So I have, so e to the 5th So e to the 5th is 148.41, and then times 4. So it's almost 600. Minus 4 times e to the 4th. Actually, I think my calculator didn't handle that quite right. So 5e dx minus 4e dx, okay, times 4. So I did it by, I instead factored the 4 out and evaluated e to the 5th minus e to the 4, e to the 4th, and that worked better. And then I just add on 8 to the result, and I get 2 decimal places, 383.26. That's my final answer for that one.